Good morning, good afternoon, good evening, depending on where you're watching this video from. Welcome back to my YouTube channel, IBDP Math Academy, where I always say that here we love mathematics. So let us continue our series on IBDP past paper questions on integration by parts. That's what we are going to do today. Okay, we are continuing. I did this one I made 2 videos before, doing question 1, question 2, 3, 4. If you haven't watched that video, please kindly watch that video. Okay. Now, before I do the next 2 questions, which are very important, I would like to review some few things and then proceed. So, when do we do integration by parts? One more time. Integration by parts happens on and only if you are multiplying 2 functions. For instance, here, e power 2x and sine x. So, you see, you're multiplying e power 2x and sine x. So, you're multiplying 2 functions. That's the first thing you need to identify. Okay. Multiplying 2 functions. That's why the formula is u dv equals to uv minus integration of v du. This formula is in the formula booklet. You can even check that. But there is nothing wrong in knowing the formula. If you know your formula, you're always fine. Okay. Now, that is the formula which will help you and is very important. Good. Now, after knowing the formula, there is another important thing which I call game changer. The next part important thing, which helps you to identify which one is your u and which one is your dv, because it's very important. So it's called the liet. So what does that mean? Logarithmic function, ln, for instance, I, inverse trigonometry, arc sine, arc cos, arc tan. Then A, algebraic expressions, are polynomials in general, x squared. Then trigonometric functions and the exponentials, e power something, sine x, tan x cos x, then here exponential e power something. Have you understood that? Whenever you're doing integration by parts, the first thing you should be multiplying 2 functions. That's the first thing. Point number two, you should be knowing the formula. After knowing the formula, it's u dv. So you need to identify which is going to be a u and which one is going to be your dv. So now that's where the game changer liet comes in and helps you. So how does liet help you? Liet helps you to identify which one is your u. So you follow this order, and what you meet first is going to be your u. So for instance, in this question, I have e power 2x, which is the e, which is exponential. Then I have sine x, which is the t, which is trigonometric function. So my u in this context is going to be my e here. I mean my u is going to be sine x. Are you together, guys? Okay, very good. Now, if that is your u, the remaining is going to be your dv. So this is your u, because you see, following the end. Now, dv is going to be e power 2x dx. Okay. Now, fast forward. Now, from the formula, uv, integration of v du. If you check from the formula, I don't have du and I don't have v. So if that's the case, I have to do derivative of u to make sure I get du. So what is the du here now? Du will be equal to what derivative of sine x, guys? It's going to be cos x dx. Okay, very good. Now, what is that? What do I do next now? I have to integrate this to get v. So what is the integration of v? Will be v, and the integration of e power 2. This is your 2 here, so it will be 1 over 2. I'm integrating, but guys, I'm not doing it derivative. Okay, you have to remember that. So I'm still on the right 2 here. Okay, now very good. Now, what's the formula? uv. So that means I have to get this times the u. So it's going to be a half e power 2x sine x. Okay, all together, guys. Okay, very good. That is my uv minus integration of. So this is a half, right? So I can even write it here. There's no problem. That's a half, okay? Because it's going to be, if you check, it's v. V is this one. So it has a half. So e power 2x, then du, which is the cos x dx. Okay, very good. Now, when you reach here now, oh, I still have the product of two functions. So if I'm still multiplying my two functions now, I have to continue doing integration by parts, okay? Now, this question is very interesting. By the way, after doing it, you pay attention and you write it down somewhere because it's a special case, okay? Maybe when I'm concluding, I will remind you this, okay? Why is it special? Now, what is going to be my u? Here, my u is going to be cos x, okay? What's going to be my dv? What is remaining, okay? What it says? What it says is e power 2x dx, guys, okay? Are we together at this point? Very good. Now, if that's the case now, again, as you remember the formula, I need to do the derivative, find the du. So my du is going to be what derivative of cos x, guys? Negative sin x, okay? Very good. Now, we need to integrate here and integrate here. So my v is going to be a half e power 2x, okay? Is that okay, guys? Very good. Because of my internet, allow me to put my video off, but my voice will remain clean and clear to make sure that you fully understand, okay? Very good. Now, can I write everything here? So it's going to be 1 over 2. I'm writing this e power 2x sine x, all together, guys, minus a half bracket, okay, bracket, because a half is multiplying everything, v. So it's going to be a half e power 2x, all together, guys, times cos x, okay, all together here, cos x, okay, then minus integration of v. It has a half again here, okay, there's a half here, very good. Then e power 2x. There's a negative here, guys. So this one I can, you see, on du. Oh, here there was the x, guys, okay? So it's going to be, this one is going to be, because of this minus, and here there is minus, so this one I'm changing it to be plus, then I write sin x dx, okay? Very good. Now, allow me to write this question very well, okay? I'll try to write small things so that they fit. Remember, what are we integrating? What's our question, guys? We're integrating this. Can you allow me to write what we're integrating? So we are integrating e power 2x sine x dx, right? So equals, I'm going to write this one. You see the reason why. So it's going to be 1 over 2 e power 2x sine x, right? Okay. Now, can I distribute this one inside? When I distribute, what do I get? I'm going to get 1 over 4 e power 2x cos x altogether here. Now, this is plus and this is minus, so will give me minus, it's going to give me minus, right? Minus 1 over 4 integration of e power 2x sine x. Wow, very interesting question. dx. Are we together at this point, guys? Okay, you can pause the video. What do we do? Because normally, whenever I do by parts, things keep on getting smaller. But I did by parts 2 times, but I still, it's not changing. So the trick in the question is to see what I have here. What I have here, you see this? Is the same as this, which is the one I was integrating initially. That's what I was integrating. So what do I do? So the best way, which I told you the special case here, I have to bring this one on the other side, on the left-hand side. I correct like terms if I can say, okay? Now, it's going to be integration of e. I'm writing this sine x dx altogether here, guys, plus, because this is minus, plus 1 over what? Plus 1 over 4 integration of e, because They are the same, you can see. Okay, sine x dx, okay, equals 2. Now, what am I remaining here now? I took this on the other side of equal sign. So what am I remaining with? 1 over 2 e power 2x sine x. Altogether, guys. Okay, very good. Double check if what I'm doing is correct. If you have any question, please see you write that in the comment, then I'll get back to you. Okay, minus 1 over 4 e power 2x cos x. Are we together here? Okay, very good. Very good. That's where we are. That's where we are. Okay, good. Now, at this point now, what do we have here? We have, I can pick a different color. I can pick red. So this is a whole number, 1, and this is 1 over 4. So, guys, what is the, can I write it here? 1 plus 1 over 4. Guys, what do you get? You're good mathematicians, I get. This is 5 over 1. That is 5 over 4. So I can add them because they're the same. This is exactly the same as that. So over 4 integration of e power 2x sine x, guys, okay? Sine x dx equals to what? Equals to this one. There's nothing I can do on these ones. So equals to 1 over 2 e power 2x sine x minus 1 over 4. Wow, very interesting question. I like this question. Okay. By the way, it's very common in the exams as well. So it's a special case which you need to know. Recurring integration. Okay. Very good. Now, remember, my main objective is to integrate this. I should remain that. So everything should go on the other side because I want to get this. This is what I have to get. So when you check here, I have this, almost got it, but I still have 5 over 4. So in other words, I have to multiply by the reverse of that. I multiply by 4 over 5 everywhere. So if I do the case, so what do I get? I'm going to get integration of e power 2x sine x. Altogether, guys, very good. Dx equals to 4 over 5 bracket. Let me keep it outside the bracket. Oh, I multiply. Are you not mathematician? Let me keep it there. So it's 1 over 2 e like that sine x minus 1 over 4 cos x. Okay, I multiply. This was 5 over 4. Then I multiply by the reverse so that I get the rid of 5 over 4. The question is over. I can even keep it like that. Plus c, by the way, don't forget that. And then the final step, the final answer here. So it's going to be, the final answer will be, if you do the question without wasting my time and then opening the bracket. Oh, there's e power 2x, guys. So e power 2x is common. I can factorize that. Okay, I can factorize that. Let me see the way to simplify that. Okay. Okay. I can keep it like that, but I want to multiply because I can see this 4 and this 2, they can simplify. I'm trying to see where I can write it. Okay, let me open the bracket. So it's going to be, when I open the brackets, I'll get the 2 over 5, guys, okay? Because it will give me 4 over 10. So when you simplify, let me simplify for you to see. This one and this one. So many with 2, okay? Then e power 2x sine x altogether here. Then what about this times that? So it will give me 1 over 5 e power 2x cos c. This is cos c x. Then plus c. Is that okay here now? So when you check 1 over 5 is common, and then also e. So that's writing it better. So I can factorize 1 over 5 e power 2x. What stays inside, guys? What stays inside is 2 sine x minus cos x, okay? Plus c. That is it. That is it. I've managed to get to the integration of my question. So this question is a special question of recurring integration. So whenever you have such a question, where you have these two, where you have the case of these two, you have trigonometric function and exponential functions, you do integration by parts twice, and then you correct like terms. Don't forget that, and it's very important. Okay, I hope you have understood. Any comment, write it in the comment, then I'll explain into the details. Okay, if there's something you have not understood. Thank you very much. So let us try to do the next question. Good. Now, oh, very interesting question by the way. So what do we do, guys? Are you ready? What do we do here? So from the question from Riyadh, let me write the formula here for you. U dv is equal to u v minus the integration of v du. So, and then Riyadh, the game changer. If you know it, trust me, you're going to be able to know which one. So basing on that, my u is going to be what? What's going to be my u? My u is going to be ln x squared, because that is it. Okay. Now that is it, because you're following your yet. So what is the dv? dv is going to be the x. Okay. Now du is going to be what derivative? This is chain rule. I hope you remember chain rule. So I have to bring 2 in front. So chain rule, I bring 2 in front. Derivative of ln x is 1 over x. And then minus on the power, so times z ln x. That's chain rule. You bring 2 in front, you do derivative of inside, and then you write this one. So you do integration here. Okay? When I do integration of this, integration here, so my v is going to be x. Altogether, guys, very good. Now, so can we apply a formula? U v minus integration of v du. So what is my v? My u is that, so it's going to give me what? It's going to give me x ln x squared. Altogether here, because that is my u, minus integration of v. V is going to be x. It's going to be x. That's my v times z du, which is z times z 2. 2, can I write it here, guys? Okay, this 2. Then here I'll get the times z ln x over x du. So this is this one was the x here, guys. Okay, sorry, the x. Okay, very good. Now at this point now, what happens, guys? This one cancels out with that. So what do I mean with? I'll mean with x bracket ln x squared minus 2 integration of ln x dx. By the way, this is very common question in IBDP question, very important. Even those who do A levels, it's a common question in your exams. So they can even ask you only to integrate ln x or even ln x squared. So you need to know that. So I have to do by parts again. So my u is going to be ln x, and my dv is going to be dx. Altogether here. So what is the du here, guys? So du is going to be derivative of ln x is 1 over x times z dx. Okay. Now you integrate both sides. So my v will be equal to x. Okay. Now what do I have here? I still have x bracket ln x squared altogether here minus 2 bracket V is going to be X ln X. Okay, that is UV. Then minus integration of V, which is X, times here, times that one. So times 1 over X dx. Okay, double check what I'm doing, please. If there's a step you don't get, let me know. Okay, now what happens here now? This one will cancel with Z. Let me use a different. So this one cancels Z with this. So what do I mean with? I'll mean with Z X ln ln X squared. Okay, altogether, guys, minus 2. I'll multiply 2 at the end. Here I have X ln X minus integration of dx. That's what I'm remaining with. Altogether, guys. Okay, I hope you understand here now. So what do I get here now? I'll get X ln squared here. Now, what is this? It will be 2x ln x altogether here. I hope you understand that step. So what about to here now? So what is integration of the x? Is it x? So times 2 here, guys. So it's going to give me 2x plus c. That should be my final answer. That should be the final answer. But if you want, you see x is common, so I can take x outside. The question is fine. That is it. But you can factorize x because it's common. It's better sometimes. So you're going to get ln x squared minus 2 ln x minus 2, then everything plus c. That is it, guys. Okay, so that is a good question, very interesting. Integration by parts. So just a quick recap, just a conclusion of what we have done. So integration by parts, you apply it on and only if you are multiplying two functions. That's the first thing. And the formula is u dv equals to u duv minus integration of v du. That's when you use the formula. That is when you're going to be using that formula. Very important. Is that okay, guys? So, and then you have to identify which one is your u. You need to identify which one is your v. And then you do derivative of u and then integrate your dv. Is that okay in your head? Very important thing. So thank you very much. Continue doing more questions, more IBDP questions. I'm planning to do integration by use substitution or differential equation. By the way, in comments, which one should I do next? Should we do IBDP questions on differential equations, or should I do it on use substitution? Which one? Let me know. Kindly, I request you guys, can you like, share, comment, and subscribe? Okay, thank you very much. IK Math, we love mathematics, guys. Okay, thank you very much. Stay safe and stay blessed. IK Math likes mathematics.